Sure. Can you see it?
Yep, perfect. So the second talk is about preprocessing in MaxSAT solving. Actually, so we haven't talked about this yet, but so I also started to work on some MaxSAT, or using some MaxSAT instances and trying to solve them efficiently. And your solver was actually by far the fastest one on the instances that I created. And I'm pretty sure, so this is Loandra, the solver by Jeremias. And I'm pretty sure it is because of preprocessing. The formulas actually have a lot of kind of redundancy in there, and they came from somewhere. And so I think I also expect that preprocessing will also become very big in MaxSAT. And Jeremias is kind of the top researcher in this direction, and I am looking very much forward to your talk.
Thanks, Martin, and thank you everyone for being here. As said, I'm going to be talking about preprocessing in MaxSAT, and this will cover work done during my PhD and to some extent also afterwards, and work I've done with Matti Järvisalo, Tuukka Korhonen, Paul Saikko, and Markus Leivo. So first, some general motivation regarding MaxSAT. In MaxSAT, we're sort of following in the trail of SAT solving and seeing these improvements, huge improvements in solver technology over the last years, which has also led to more and more applications of MaxSAT. So for those, if there's anyone who doesn't know, MaxSAT just simply refers to the optimization version of SAT, you could say. So you're trying to find assignments that satisfy as many clauses as possible, or as many, or as much of the sum of weights of clauses as possible. So here's a sort of word plot done by Ruben Martins on the submissions entries in Google Scholar. And every year we see more and more domains submit benchmarks to the evaluations. So MaxSAT is really a sort of blooming area. And as I mentioned, this can also be seen in solver technology getting better and better. Here's a sort of inverted cactus plot where you want to be as high up as possible. You got different timeouts on the y-axis and the number of instances on the x-axis. And we see the winners from the past 10 MaxSAT evaluations run on the benchmarks from last year using the same hardware. And we can see that the winner in 2010 solved approximately 200 instances, and the winner last year solved over 400 instances. So that's around 81% more instances solved in 10 years. And in addition to solver technology itself and SAT solvers getting better, I would argue that much of this improvement is also due to more and more solvers making use of different kinds of preprocessing. And the motivations for why you would want to use preprocessing in MaxSAT are very similar to what we heard Benjamin say. When you encode your problems as CNF, you might end up with lots of redundancies, and you want to use sort of automatic techniques for removing these redundancies and making your formula easier for a MaxSAT solver to solve. Here's an experiment we did a few years ago on all of the benchmarks used in the evaluation. Here we got the number of variables and clauses on the right, variables on the left, of a non-preprocessed instance on the y-axis, and then the preprocessed instance on the x-axis. And we can clearly see that preprocessing in most cases can significantly decrease both the number of variables and the number of clauses that appear in these instances. And there's a very good reason for this. One exception might be this sort of part here where we have some more variables, and I'll get to why this is during my talk. So here's kind of the outline of what I want to talk about. I'll start with some very simple definitions to make sure that we're all on the same page. Then I'll talk first about MaxSAT preprocessing in practice. What kind of problems do you run into when you want to use your preprocessor together with your MaxSAT solver, and how you can solve them? And then depending on how long that takes and how many questions there are, I'll also touch a bit about MaxSAT preprocessing in theory, what we know and what kinds of interesting research directions there are to be there, and then end with some concluding remarks. So here's the sort of the basic definitions, just to get us all on the same page. In MaxSAT, we're given a CNF formula, which can be seen as a set of clauses, and then we're looking for a truth assignment tau that satisfies as many clauses as possible of the formula. So you want to maximize the number of satisfied clauses. This is called sort of non-partial MaxSAT or MaxSAT, and it's often the formulation that you see in theoretical computer science and theory papers. But for solving real-world problems and industrial applications, the stuff I'm interested in, this is not very feasible. Instead, what you want to do is you want to work with something called partial MaxSAT, where we are instead given two CNF formulas, the so-called hard clauses and the so-called soft clauses. And then now we're looking for a model of the hard clauses that satisfies as many of the soft clauses as possible. So you can think of this like the hard clauses defining your set of feasible solutions, and then the soft clauses defining some kind of optimization criterion that you're trying to optimize over. And for simplicity, I will be sticking with partial MaxSAT, unweighted partial MaxSAT in this talk, but I'll say here that you can also have weights on the soft clauses, and everything I'm going to talk about is directly applicable in that case as well. If you have weights, then you're trying to maximize the sum of weights of soft clauses that are satisfied. So this is the sort of only example I'll be working with. So I'll spend a bit of time here because I'll get back to this. Here we have 4 hard clauses and 3 soft clauses. And an example of an optimal model sets x1 and x2 to false and y and z to true. It satisfies all of the hard clauses and leaves one soft clause falsified. So we say that it has cost 1. And you don't need to remember the instance, but you can remember that the optimal solution to this instance has cost 1. And still, before getting into the sort of meat of the talk, I'll set up my own context a bit. Very roughly speaking, MaxSAT solving can be divided into 2 sort of areas. We have the so-called branch and bound MaxSAT solvers that have been shown to be effective on smaller, hard, and often randomly generated instances. But as I already said, I like to work with sort of industrial applications and real-world problems. And over there, the sort of dominating way of solving MaxSAT are the so-called SAT-based MaxSAT algorithms, which make extensive use of CDCL SAT solvers and different ways of reducing MaxSAT into a sequence of satisfiability queries. And similarly, the field of MaxSAT preprocessing can roughly be divided into 2 areas. You got preprocessing techniques based on the so-called MaxSAT resolution rule. That is an extension of the resolution rule that Benjamin talked about to MaxSAT. And rules based on MaxSAT resolution are often used in these branch and bound solvers. And then the thing I worked on during my PhD and what I'll be talking about here is what I call SAT-based preprocessing in MaxSAT. And here we want to lift these nice and effective preprocessing rules from SAT to MaxSAT. And in the first part here, I'll be talking about why that is hard and what you can do to make it easier. Are there any questions at this point? Doesn't seem to be.
No, there's nothing in the chat.
So we can just move on. So the motivation here is, well, since these SAT-based MaxSAT solvers make extensive use of SAT solvers, and as we heard, preprocessing is central in SAT solving, it's a very natural question to ask. Can we use the nice work being done in SAT preprocessing to solve MaxSAT better? And here's my a lot less. My sketch of the pipeline that we want to achieve that is a lot less nice than the one Benjamin had. But just to recap, the thing we're aiming at is a pipeline where we start with an instance F, and then we run different kinds of preprocessing techniques to obtain a preprocessed instance. Then we solve the preprocessed instance and find a model for it. I'll say here that in MaxSAT, we usually assume that there exists models. So the case where the hard clauses are unset is not that interesting. So I'll mostly just be assuming that there always exists some model. And then we reconstruct. We take the model for the preprocessed instance, and then we obtain a solution to the original instance. There are sort of standard algorithms you can use for this. And the first fairly simple observation to make is that this does not work directly for MaxSAT. So here we have the same instance as before. And if we now run, for example, bounded variable elimination just freely on this instance, it's fairly easy to show that you can eliminate all of your clauses, both hard and soft. And now this instance is trivial for a SAT solver. It can give you any assignment it wants to. It can, for example, give you this one. And on the side of the preprocessed instance, this assignment that sets x1 and x2 to true and the other ones to false, it doesn't falsify any of the soft clauses because there are no to falsify. So it has cost 0. But if we now try to reconstruct this, we get the same instance back, and actually we're falsifying two of the soft clauses. So this assignment has cost 2, and earlier we saw an assignment that had cost 1. So this is not optimal. So we had an optimal assignment for the preprocessed instance, but then when we try to reconstruct, we get something that's not optimal. So directly applying these techniques, it's not sound for MaxSAT. And one possible way of making it sound or fixing this problem. Well, okay. So as we heard Benjamin say, the problem is essentially that preprocessing preserves satisfiability. It does not preserve the cost of models, or in some cases, not even the same models. And how do we fix this? Well, there was a paper from Bello et al. In 2013 that proposed the use of so-called labels. These labels have many names, but I'll stick. They can also be called assumption variables or reification variables or blocking variables, depending on in which context you're working. And the idea is that we start with a MaxSAT instance having the hard clauses and the soft clauses, and we add this label variable to each soft clause. So we take a new variable, I'll denote by L of C, and extend each soft clause with this label variable. And now we can run a SAT-based preprocessor on the union of the clauses, of the hard clauses and these extended soft clauses. And the only thing we have to restrict the SAT preprocessor from doing is resolving on these labels. So you can do anything except resolve on these label variables. And then you run it for as long as you want to, either to fixed point or not, and output whatever clauses remain. And then you say, these are my new hard clauses. So whatever remains after preprocessing are the hard clauses. And as soft clauses, you take a unit negation of each of the label variables that you added in the first step. And now you call your MaxSAT solver on this instance. And you obtain an optimal solution to this preprocessed instance. And now you can run the same standard SAT reconstruction algorithms to obtain an optimal solution to the original instance that you started with. So we can go back. Let's go back to the example one last time. I already mentioned this. Labels is, I'm not sure I quite like the term. I'll use it here because of that's what they used in the first paper. But you can think of them as relaxation variables or blocking variables. So now the same instance one last time. We start by we have 3 soft clauses, so we take 3 label variables and add them to our soft clauses. And now we run a SAT preprocessor and tell it to not resolve on these variables. And when it reaches fixed point, what remains are these clauses. So we got two hard clauses remaining after preprocessing. And then we take a new soft clause for each of the 3 labels that we added in the first step. Now, when we solve this MaxSAT instance, we get an assignment like this that sets L1 and L2 to false and L3 to true. And if we now run the standard SAT reconstruction algorithm on this model and then ignore the label variables, we see that we get back exactly the optimal solution that we had in the first step. So this is what we did. I think it was among the first papers in my thesis. And the thing we observed was that it doesn't work. So here's the quote unquote normal cactus plot. And the line here, you want to be as far to the right as possible. And the line in the middle here is our own implementation of an so-called implicit hitting set based algorithm for MaxSAT. And if we run preprocessing in the way I just described, what we get is this green line over here. So we actually end up solving less instances and doing worse. But luckily, there's a fairly simple solution that fixes this problem. I'll not go into too much detail, but as long as you tell your MaxSAT solver to use the labels as assumptions. So MaxSAT solvers add a lot of assumption variables to control soft clauses. So instead of adding the unit negation of a label as a soft clause, you use that label as an assumption directly. And then you end up with performance corresponding to this yellow line over here. And it's a fairly simple trick. And nowadays, most of the MaxSAT solvers that I'm aware of do this. But the point I want to get across is that doing this is not required for the correctness of a MaxSAT algorithm. So if you just take any MaxSAT solver that you don't know of and you try to use preprocessing in a black box manner, you might end up just worsening performance by accident, even if reusing labels as assumptions would fix that. And while this fixes the first problem, more recently we've looked at what happens to intermediate solutions found during SAT solving. And we see that there's still other issues to be solved when it comes to integrating MaxSAT solving and MaxSAT preprocessing. The plots over here show the difference between the cost of a non-optimal solution obtained during search as computed on the preprocessed side and on the original instance side. So to say that in another way, what we did was that we took every solution found by a solver, and then we ran the reconstruction algorithm on that solution. And then we compared the cost of the reconstructed solution with the original solution. We see that there's actually quite a big disparity. The cost of the preprocessed, the cost of the solution to the preprocessed instance can sometimes be 3 times higher than it actually can be believed to be 3 times higher than it actually is. And this is a problem because many effective implementations of MaxSAT algorithms make use of these intermediate solutions to obtain bounds on the cost. Any solution is going to be an upper bound on your cost. So if your solver thinks that it has a solution that's 3 times worse than it actually is, then the heuristics that build on these bounds are not going to be as effective. And in the paper I cite here, we proposed a solution to this in the context of local search for MaxSAT, but fixing this in an effective way for these other MaxSAT types of MaxSAT solvers is still an interesting future research direction. And then I'll end this part of the talk by saying that in addition to these sort of liftings of common SAT techniques, nowadays many solvers incorporate various heuristics that they don't call pre-processing, but that in practice are pretty much like MaxSAT specific pre-processing techniques. Many of the so-called core-guided solvers use stratification and hardening, where you use the bounds you have on your optimal cost to deduce that some of the soft clauses need to be satisfied, so you can harden them. If your soft clause is too expensive to be falsified, then you can just harden it. In the field of implicit hitting set solving, there was a paper on how you can use these reduced costs, which are a common technique in mixed integer programming, and you can sort of transfer information you learn from them to MaxSAT to again fix soft clauses to true or false. And there are some other techniques also which consider, for example, partitioning soft clauses to make solving easier. But in contrast to sort of, at least my understanding of SAT preprocessing, the field of MaxSAT preprocessing is a bit divided. So these are heuristics that are bound to specific solvers, and there's not, and unifying the theory underlying all of these could be very interesting in the future. So here's the take-home message from this part, and it is that preprocessing can be very effective in MaxSAT as long as you make sure that your solver supports it. So black box integration between a MaxSAT preprocessor and a MaxSAT solver there's a very good chance that that won't be effective. But if you do some careful integration between the two, you'll often end up winning, as you do in SAT solving. Any questions at this point? The second part is shorter.
So I'm just curious about, MaxSAT, you're kind of stepping on the territory of very close to ILP.
Yes.
In my opinion. What can we learn from them? What can we teach the ILP people, and what can they teach us about this?
It is a good question. The reduced cost fixing is one example of something that they taught us. Other than that, it could be interesting to. I've thought a bit about these cuts that are commonly used in ILP, and if you could somehow use them in SAT. There doesn't seem to be a clear way of doing it, because mixed integer programming is a bit more expressive than clauses. But for sure, I'm sure you could do something, but I'm not aware of too much work in there yet.
Thank you.
Okay, so then I'll spend the rest of my time talking about sort of the theory underlying SAT-based MaxSAT preprocessing. And the only definition I'll be using is that of a core or an MUS. We say that a set of soft clauses is a core if it's unsat together with the hard clauses, and an MUS if it's subset minimal. So no subset of the set is a core. And I'll denote the set of all MUSs of an instance like this. And why is this relevant for MaxSAT? Well, it's fairly easy to see that every solution to a MaxSAT instance needs to falsify at least one clause from each MUS. So already in the first paper proposing this label-based framework, they showed that if you preprocess an instance using these techniques that Benjamin also talked about from SAT solving, bounded variable elimination, etc., you obtain another instance, then the preprocessed instance will have the same MUSs as the instance you started with. And in my PhD, we took this result and showed that it implies that the best case number of iterations, that means SAT solver calls, required to solve the preprocessed instance will be the same as the original instance. So an informal way of saying this is that SAT-based preprocessing with these techniques for MaxSAT can only sort of speed up your individual SAT solver calls. It cannot decrease the number of SAT solver calls that you need, at least not in the best case.
Jeremias, so there are two kind of questions regarding some explanation. So is it so? The question is it relevant to find which clause causes unsat?
It depends on your application, but often if you find an optimal model and you know it's optimal, then finding which clauses are unsat is trivial. You just check the model, check all the clauses against the model. So it's usually quite easy, if I understand the question correctly.
And also the question whether you need to find one maximal solution of all of them.
Typically, you work in cases where you just want one optimal solution, but there's nothing stopping you from it. If you want to have more of them, there is some work on enumerating MaxSAT solutions in the same way as there's work on enumerating SAT models. So, and the way you do that is pretty much the same. You add an extra clause that says that you want to get something else, and then you keep going. So you can do both.
Okay.
But doing a good point here is, of course, that doing preprocessing and model enumeration is unclear. This is how I'm not sure how that will work. And so for preprocessing, I'm mostly concentrating on the situation where we want one optimal solution.
Okay, thank you.
Okay, so after my PhD, we sort of generalized this result a bit. I will not go into details here, but a few years ago, we proposed this extension of so-called resolvent asymmetric tautologies to MaxSAT. With the RAT clauses are what you can use in SAT solving as basis as a sort of theoretical foundation for many of the techniques that Benjamin talked about. And we showed that you can have this concept of a RAT clause for MaxSAT, where an informal way of saying the definition for those of you familiar with RAT clauses is that a clause has RAT in the MaxSAT sense if it has RAT in the SAT sense on a non-label variable. And we also showed that if you use any kind of preprocessing technique which can be seen as the addition and removal of these RAT clauses, then you won't affect the set of MUSs. And this is a fairly general result because most of the techniques that Benjamin mentioned, and I'm not sure about hyperbinary resolution, but the other ones can be seen as addition and removal of these RAT clauses. So this is a very general way of showing that most techniques that you lift from SAT solving won't affect your MUSs, and again, won't affect the best case number of iterations that are required by SAT solvers either. So the take-home message for this part is that significantly altering the execution of MaxSAT solvers requires techniques that are able to alter your MUSs. And the liftings of these commonly used techniques in SAT solving do not do this. However, again, there are these heuristics that have been proposed as parts of solvers that actually can change your MUSs. The hardening that we talked about, the reduced cost fixing, and a technique of my own which we call subsumed label elimination, they can fix soft clauses that are parts of MUSs to harden them, so force them to be satisfied. And then there's also this technique that the authors called for intrinsic at most one constraints that can actually alter the MUSs of the formula. And that actually has been shown to be very effective, implemented in the MaxSAT solver called RC2. So in my view, a very interesting future research direction here would be to sort of trying to unify all of these existing techniques under one theory and see what could come out of that. And these PR clauses that were mentioned in the discussion after SAT solving I think there could be some interesting connections to be made there, sort of generalizing that to MaxSAT or extending that to MaxSAT as well. So I'm pretty much almost out of time. I'll sum up. So preprocessing, as we saw, it can be for MaxSAT, can also be very effective for MaxSAT, but you need to be very careful on how you combine your solver with your preprocessor. And currently, the field is a bit divided, with lots of solver writers developing these very nice heuristics for their solver, that heuristics that could be used in other solvers as well, but usually tend to end up not being used because they're just part of the solver code instead of a separate preprocessor. And if you want to try this, we have a MaxSAT preprocessor called MacPre. And then there's also another one that I'm aware of called coprocessor by Norbert that I believe are freely available on the online. And if you want to learn more about MaxSAT, Fahim has given a talk in this seminar, not this seminar, but at the Time Institute. And we gave another one with Matti a few weeks ago. And now this is already, I did not know that the second volume of the handbook is already published, but there's a chapter on MaxSAT over there as well. And that's pretty much all I wanted to talk to you about. If you have any questions, I'll happy to take them. Otherwise, I thank you all for your attention.
Thanks for your nice talk. Are there questions? Maybe let me start with a question. So what about in-processing for MaxSAT?
That's another very interesting direction. For these core-guided solvers, for example, the difficult part is the fact that the cardinality, now I'm getting a bit more technical, but the cardinality constraints that they add are often very sort of tight. They're not, I've sometimes played around with what preprocessing could do to those, and it does not seem, if you preprocess your instance and then you try to do just on the clauses added by the MaxSAT solver, you often end up not doing anything else. But if you could effectively use the learned clauses of the SAT solver, you could maybe do better. I've done some very preliminary tests, but I haven't been able to make it work effectively.
Okay, looking forward to follow up on that. Armin, you have a question.
Yeah. So you of course mentioned this already. So there's this PR clauses, and of course we even defined like in general what redundancy mean. What's your take on this? Do you think these PR clauses, or even maybe the semantic redundancy, would give you something? Could it not be the case that the MAS is still, even for semantic redundancy, would stay the same?
What did you say in the end? What would stay the same?
So you have the MOSs, right? They would not change for preprocessing.
No,
now, if you go,
sorry.
Okay.
No, you can. One of the techniques that the one I mentioned, subsumed label elimination, can be seen as a type of PR clause. So you can change MESs with PR clauses. I'm very sure of this.
So the real question is where the line is, right? Like you want to have a maximum definition of what keeps the MOSs. Okay, I see. Thanks.
Yes.
So are there any other questions? Otherwise, let me, I have maybe one more kind of high level, or because do you know how many more instances, so percentage-wise, would you solve by turning off preprocessing kind of in your solver? Are you aware in the competition or the competition results? How big of an impact?
That's a good question. I mean, the solver that you mentioned in the beginning is incomplete, so there is more about how fast can you solve them. For complete solvers, I don't have any like hard numbers, but my intuition is that you mostly win on how fast you solve them. If you have a timeout of say 2 hours, then Usually most of the MaxSAT instances are either solved faster than that or not at all. So preprocessing mostly decreases the amount of time you spend solving, and not yet too much on the, like, does not yet increase the number of instances solved by too much.
Okay. Yeah, no, I can, yeah, no, let's take this also further offline, because I also have some follow-up questions, because more of my specific instances where it is, where I think I can see that it has been very useful, because these require very long runs, right? And that's,
yeah. Well, yeah, that could be, if you have really hard instances, then the situation changes again, and you have long runs, then you got, of course.
Okay, thanks again. And so now we go to the last talk in the session, which will be by Martina. So